Hello colleagues. Today we are giving a pretty deep introduction of our new robot, which we call Marvelmind Boxie. What is this robot for? Now, first of all, it is for autonomous delivery, for research, for education and overall development. So let's jump to the basics. The robot is about 31 centimeters by 31 centimeters. It has a height, I don't know, 15. I will ask my colleague to bring a meter and we will show you more details. The weight is 4.5 kilos. And it has the following kinematics. So it has two driving wheels, it has two caster wheels, and the chassis is made of metal, so it's very rigid because their payload capacity is up to 10 kilos. What can it do? Now, first of all, what is the robot? The robot is must be capable of doing three major things. The robot must be capable to sense the environment. This is why the robot has plenty of different sensors, and sensor fusion in general is the key for any autonomous robots. Second, the robot must be able to process the information, to record it and recall it from the memory from the previous past, and the robot must be able to actuate, to affect the environment around. In our case, it's delivery, first of all, but not only. It has plenty of other interfaces that we will be talking about, because this robot is developed to be expanded. So effectively, it's a tractor. So it's designed to have additional equipment installed on this. So what you see here is what we call so-called standard configuration. So it already has the base, it already has the Intel RealSense lidars and 3D cameras, and it has standard batteries. The base configuration, if you go to our website and check it, the base configuration would be the same, but without Intel RealSense. And the advanced configuration would contain everything the same, but additional batteries for more capacities inside, and quite a few other things like stationary beacons included, additional warranty, and additional training when you need it and if you need it. So let's jump a bit back. What are those sensors? Now, many, because the environment in which a robot operates is challenging. And that's exactly what differentiates the real robots from the robots which are used, let's say, for laboratories or for demo cases. Because the real environment in the warehouses, assembly plants, in their, let's say, manufacturing facilities is very challenging. You can have noise, you can have lights, you have no lights, and the robot must be able to operate in all this environment using 1, 2, 3 or many more sensors, using sensor fusion. So what are those sensors? Now, of course, our own precise unknown navigation system. So as you can see, there are two Omni microphones. Each of the microphone they have each of them Omni microphone has 4 microphones. So this is why they are covering 360 degrees in each microphone, and there are two. And the base between them allows you to measure not only very precise location, but also the direction, because you calculate the position of each of these dots with centimeter level precision, and then knowing the base, you can know the direction where the robot is facing with a couple of degrees accuracy. And of course, this works always together with inertial management unit. So this robot contains several IMUs. Inside the robot, there are 2 super beacons effectively embedded, and you can see those microphones from the super beacon, and you can see their transducers, which are used in this case as sonars, but they are part of the super beacons which are inside the robot. So IMUs are on the super beacons and it's available, so you can use them. And as usually, IMUs, in this case gyros, is drifting. In order to eliminate the drift, the paired beacons configuration cancelled this. So it means that you have at the same time super precise and super accurate IMU, and at the same time without no drift, because the drift is eliminated using the paired beacons configuration. So that's not different from typical paired beacons configuration which we are offering as our paired beacons, or it's not different from a larger brother of this small girl, our robot for industrial applications V100. Its implementation in this. So precise indoor navigation and positioning plus location and direction using the paired beacons. Of course, since this is a robot and we are all the time talking about the sensor fusion, it is using not only this for positioning but also odometers. So there are two wheels. Each of these wheels have embedded odometers, and those odometry data is available to you also through API, and of course is used by the robot for the autonomous driving. So it's sensor fusion between their positioning, the IMU and odometer. But we know that in many cases a customer prefer options, not necessarily a must, but an option to use optical navigation. Yes, for these purposes we are offering Intel RealSense 3D and LiDARs. LiDARs are obviously used for building their environment and knowing the obstacles, and 3D for localization and positioning. And together this is a perfect solution. But there's a big but between their optical based solutions and indoor GPS solutions. With indoor GPS solutions, if you travel, for example, 50 meters, you can return to the same point with 2 centimeter accuracy. It doesn't matter how much you travel, you can always return with 2 centimeter accuracy. So that's kind of absolute positioning. With optical tracking, it's not absolute positioning, it's always relative tracking. RealSense works very well and meets the requirements, and they give about the closed loop 1% in accuracy. So it means that if you travel, for example, 100 meters and return back, that officially you can be up to 1 meter away from the point where you started, which can be pretty much for the robot of this size and in general. So it means that optical is very good for, let's say, traveling and overall traveling without additional beacons, because, for example, our indoor GPS does require the network of stationary beacons around, but at the same time is not without limitation. So this is why we are offering you a choice: indoor GPS only, indoor GPS with location plus direction, plus odometry, plus RealSense as optical to complement the sensor fusion. That's about the positioning of the robot, which is the key requirement for autonomous driving, autonomous navigation, autonomous positioning. But you also have the obstacles around. You need to overcome those obstacles, detect those obstacles, and drive around them. So we have several sensors handling this. Now, as mentioned already, RealSense does the job as well. But sometimes it's just too complex to implement. You really need a lot of calculations and a lot of software in order to overcome those. We have additionally 1D LiDARs, which are used for obstacle detections. They can detect up to 4 meters in dark environment. In the typical environment, very bright light environment, it's up to 1 meter. We recommend at least that. Of course, that data is also available to you through the API. Effectively, let me not to repeat. Everything what I'm talking is available for the self-driving, but also for you to develop your system on top of the robot through the APIs. If something is missing, especially in the beginning, let us know and we would enable this, because we are using this and we are happy to enable this API to you, so it means that you can build and, for example, take over the control of the wheels. Yes, the robot drives using our own self-driving system and the software, but you can do this by yourself. So you can use the robot as the ready-to-use chassis with the hardware, with the drivers, with the software, and many other elements like sensors, but you can build your own self-driving mechanism and not use ours through the APIs. So I will probably repeat this, but remember. So LiDARs. So there are LiDARs, several of them, 2 in front, 3 on the corners. Well, let's say 2 on the corners and 1 on the side, and a couple of on the back side. But those are optical. Sometimes you may face the objects which are providing the obstacle, but not visible to the optical LiDARs. For example, too reflective, or too translucent, or just like a mesh. So you cannot detect a mesh using the LiDARs, or sometimes you cannot. So that would be pretty difficult. In order to help overall, as long the same logic is applied for positioning and sensor fusion, but the same logic is applied for obstacle detections. So you have, once again, real sense, 3D LiDARs, you have our own 1D LiDARs, and you have also sonars. So all this together combined helps robot overcome and detect the objects in real environment. Of course, additionally to this, there are some other sensors which you can probably not treat as sensors, but they are. For example, you are measuring the current of consumption, and the robot is driving, like regular driving, and you sense the current which is consumed by the motors. And then suddenly, for example, you miss everything. You miss by sonars, you miss by LiDARs, 3D LiDARs, by everything. Objects like this. Very difficult to sense because it's sharp, it's thin, it doesn't reflect back, and for example, you didn't notice, or let's say the robot didn't notice. And the robot simply, start pushing. And by sensing the current, you can detect there's some change in the driving. So, and current sense from this perspective is also an element of obstacle detection and, as a result, avoidance. And of course, by definition, you use the current sense in order to estimate your battery lifetime, your communication with the customers and the users, etc. All this is available. So sensor fusion as a mantra is a key for any autonomous robots, and we have plenty of different sensors inside. But sensors is one of the elements of autonomous robots, but not sufficient. So you must have a processing power. So let's talk about the processors and the boards and the overall processing what you have inside. Now, we have several layers and several boards. Now, the key is a Raspberry. So we have a very famous Raspberry Pi installed inside. This is a tiny, low-consuming Raspberry Pi Zero with wireless connectivity. So it automatically gives you a very strong Linux and Raspbian and ROS on Raspberry Pi. And of course you have interfaces available to you. They're the standard 40-pin interfaces, absolutely the same as you can see on the web. So they are available. Some of them are used internally, but the majority are used and available to you directly. So Raspberry Pi is the key, let's say, high-level computer and processing. We are using it but the majority of power and the majority of, let's say, memory is available to you for your external devices that you will be using along and on top of the robot. But that's not the only one. Of course, we have our own boards inside. So these pins are for the odometer board. And this odometer board also have 40 pins, but those pins are, let's say, lower level. So what are they? Well, for example, you have an equipment and you want to switch on or off some of your, for example, arm or your camera or some gripper. So you can power it directly from here, 12 volts, 5 volts, and you can have the ground down. So it means that you can provide like 40 volts and then ground switch on and off. So everything is from these pins, and everything is, of course, API available. Additionally to this, you have a display, which is basically an Android phone. So you have two high-level processors. You can run Raspberry with ROS, and you have the Android. So it's up to you in terms of the end-user interface. Let me jump a bit faster forward, and so there's HDMI, and this HDMI is connected to the Raspberry. So it means that you can easily connect a mouse and keyboard and HDMI and upload your software and your program directly to Raspberry and run it natively over there and debug everything what you need. Even more, you can power, for example, a display or the monitor from some of the sources or from external additional battery installed here, and you can even run with the monitor installed on the robot if, for example, your development requires this. But let's return back to the computer. So what computers available to you? First of all, is Raspberry as a high level, then our odometry board, which is the main controlling board to all other boards, which gives you a direct access to many elements like power supply switches, like direct control of the data which is received from the super beacons, and many other lower level elements than Raspberry. And on top of this, as a user interface, you have their Android phone, which provides many other things, but let's talk about this a bit later. About the chassis. Now, as mentioned, their key application is delivery from point A to point B. So check our videos, so it can carry up to 10 kilos absolutely without problem. And it's very rigid, so it's made of metal. I think it's 2 millimeters or 1.5 millimeters. Anyway, so it's very rigid. So it's designed to carry a huge capacity. But, you know, recommended is up to 10 kilos. The battery inside is effectively limited by their maximum capacity, which is allowed to be sent over the air. So it's 100 watt hours that allowed today to be shipped. So that's the maximum capacity we recommend to install, and that's the maximum capacity that has their advanced configuration. In the base configuration, it's smaller, and in the standard configuration, it's in the middle. What else? The chassis, as you see, have many holes. Those are not for ventilation. Those are designed for your particular boards. What are those boards which the holes are already pre-designed? It's, of course, Arduino. Yes, it's pretty weird to install Arduino on such an advanced robot, but why not? So there are holes specifically designed for Arduino. There are holes specifically designed for additional Raspberry. We always recommend, if possible, install your own Raspberry, take the power supply either from USB or from this source and run your program or your whatever applications absolutely independently from our Raspberry. that simply simplifies the development. So Arduino, Raspberry, and Jetson. So you can install Jetson as well. So you can install all of them or some of them, up to your choice. And of course regular mounting holes just to install your additional equipment like arms or whatever boxes or whatever thing you will be carrying using the robot. If you need slightly different configuration, let us know, because this is configurable. We can produce it on demand based on your particular needs and based on your particular requirements. A bit more words about the battery. Yes, so since the robot needs to carry pretty much and drive pretty long, effectively all this area is battery, let's say, designated to the batteries. The default battery is was it 4,000 milliamps or amps hours. So it's about 50 watt hours overall capacity, and the maximum is 100. But the maximum inside, you can easily install the layers of batteries, whatever, up to 10 kilos of batteries if you wish so on top of this, and then connect internally. It's very, very simple. I will ask my colleague to bring the battery and I will show how the battery, so it means that it would be very, very easy to connect additional batteries if you need so. The battery is 12 volts, so it's pretty common voltage and easy to use and easy to handle. So let's talk about interfaces. As I mentioned, interfaces is this, so before the interfaces, a couple words about the battery. So similar batteries are installed inside, and you can, connect more and more by simply connecting like this. So by connecting more, you can first of all install additional batteries inside like this until you fill it completely. And I mean that's inside, and there's a special holder that holds the batteries. Or if you need, you can install huge layer of batteries here, and then the capacity is I don't know, tens and tens amp hours of 12 volts batteries. So about the interfaces. Interfaces is another very important element for any robot, because the robot must sense the environment, must process the environment, and must output the environment. The main output is the delivery, so it's basically driving the motors, but not only. So what are those interfaces that the robot has? Now let's again, since I already showed, it's USBs. USBs is the simplest, the easiest. These USBs are connected to Raspberry, but many other boards are connected to Raspberry as well. What are those boards? No, odometer, of course, Intel RealSense, and super beacons. So there is a pretty extensive USB network inside the robot, and 6 external USB interfaces are available here, and additional 1 interface is available inside if, for example, you decide to connect something which must be installed on the top and you don't want to use the back side of the robot, so you can put the USB over there. What else? HDMI, very, very convenient to run your program on the internal Raspberry if you need so. Then, of course, the power supply. This power supply is kind of final switch on and off when you storage it. In normal conditions, we recommend never to switch off the robot, because the robot is always alive, and you can send the robot to sleep. Like any Marvelmind devices, you can send the robot to sleep and it will sleep, and then you can wake up. And so you don't need to switch it off physically. But when you store it, or when you send it, or when you ship it, so then please use, of course, the external switch which cuts off the electricity completely. Charging, regular charging, 1 amp, that's what we supply to you. And if you have a need for faster charging, then we supply an optional fast charger. This fast charger is around 5 to 10 times faster than this one. So particularly if you have larger batteries inside, then the optional fast charger is a great. We have couple of buttons, but those are, you know, like mouse buttons. You can assign many different tasks to them. Currently, they're, you know, just switching between different modes, and this is kind of pause and sleep mode button. But those which are currently assigned through the API, you can assign nearly anything. So it's kind of functional buttons when you don't want to control and you don't want to install anything else, you don't want to control through the dashboard. So these are functional buttons which you can assign nearly any functions from the robot to these buttons. And of course reset. There must be reset always. You know, our robots are reliable, but reset must be always. So what about their, again, let me remind that these are 12 volts batteries, so 12 volts chargers are provided. What are the interfaces? These 40 pins. You can see there are 40 pins from Raspberry. I2C is available, UART, SPI, audio in stereo mode, and some general GPIOs are available there. In this, nearly the same, but more. I already mentioned switching on and off the power for external devices. First of all, I2C to have a lower level control, for example, of LiDARs. So you can get the same data through the API, either from their odometer board or from Raspberry. It totally depends on your application. It totally depends on the depth and the level you want to have towards the system. So I2C is available, UART is available, SPI is available, powering 5 volts, switch on off, 12 volts, switch on off, ground, switch on off, something else. Check the manual for more details. But that's a physical connectivity. Physical connectivity is of course great, but not everything. There's also wireless connectivity, and we have plenty of wireless connectivity inside the robot. Now, first of all, Wi-Fi. So since we have Raspberry Zero, it provides the Wi-Fi connectivity directly to the Raspberry Zero, which is easy to use. There is of course Wi-Fi inside the phone as well. Sometimes it's convenient, and it's convenient for the applications which are running on Android. But for, let's say, more robotics applications, not interface type of applications, this Wi-Fi would be recommended. Bluetooth over there as well. On the phone, you have 2G, 3G, and 4G, and of course you need to provide your own SIM card, so it's effectively your own regular phone with Android, which you are using as a display, and many other nice things like I already mentioned 2G, 3G, 4G connectivity, additional Wi-Fi if needed, but also GPS. Yes, the robot is designed mostly for internal applications, but why not to use GPS if it's there? So yes, it's available to you as well through Bluetooth. What else? Let's talk about sensors a bit more details. I already mentioned the LiDARs, but those LiDARs from real sense, basically you can reuse them right away. Now, first of all, you can use them here and connect your external devices through the USB, but you can use them as well on Raspberry as a part of sensor fusion. But in this case, you know, you need to operate pretty deeply to extract this data from their sensor fusion, because we are using this by ourselves. If you kind of disconnect this data source, then you can do, you know, multiple things on your own, on your external boards, but then you are responsible also for the sensor fusion in general. So your board must be doing the sensor fusion on top. What else is on the front panel? LEDs. So the LEDs, let me run them. So the LEDs are used mostly for optical communication between the robots, the optical communication with the users, and as real lights to help real sense in the dark environment. As mentioned in the beginning, there is always a challenge with different type of sensors. When you have too noisy environment, the ultrasound positioning may fail because it's just too noisy around. Or if you run under the table and the station beacons are not visible, then you need to rely on the odometer and real sense in order to drive out. Both odometer and real sense, they accumulate their error, and then you cancel the error by using the absolute positioning of indoor GPS, ultrasound-based system. So all together works perfectly. All by itself may have some challenges depending on the environment. So the optical obviously have challenges when you don't have the light around and you need it. So these LEDs are providing the light. Sonars. Now, sonars I mentioned, typical sonars, nothing fancy. These are emitting, these are receiving. So first of all, you can detect objects around, typical objects which are visible to ultrasound. And you can even slightly know the direction to the objects, because you can emit only by this and listen by this and then know the direction to the object, or emit by this and by their time difference of arrival know the direction of the object. So it gets additional data for the obstacle detection, not only I'm hearing with this, so the object must be somewhere here. No, it's more precise than that. So summing up, again, the robot is designed for delivering, for installing additional equipment, and there are many different use cases, the real long tail of use cases. It offers a great flexibility in terms of connectivity through the high level, through the low level, through the powering. And oh, by the way, I didn't mention additional camera, the up-facing camera, which is used for example, for QR codes or for positioning. So it's of course connected with the Raspberry. So it's a standard camera provided. So it complements all other systems, and it is a part of the sensor fusion for different. So rigid, capable for expansion, easy to operate, and flexible in general, because we know that there are so many different applications that customers are using our robots for. It's flexible by design, but if you need something more, if you need something special, or if you like to add something, just let us know. We are flexible in that as well, and we are happy to build a particular customized configuration of this Boxie robot. So thank you very much.